Today we are going to talk about how to prove specific angle relationships in triangles using statements and reasons. So the first problem we looked at in class said if triangle ABC can be an isosceles triangle and the angles of the triangle fluctuate according to time in seconds. Angle A is equal to t squared plus 10t plus 30 and angle B is equal to negative t squared minus 10t minus 18. Would it be possible to have angle A and B be the base angles of this isosceles triangle? So we know the base angles of an isosceles triangle have to be congruent. So if we want A and B to be the base angles, then we want A to be equal to B. So we will set those two angles equal to each other. T squared plus 10t plus 30 has to equal negative t squared minus 10t minus 18. Since this is a quadratic, I want to make one side equal to 0, keeping my t squared positive. So I will add t squared, add 10t, and add 18 to both sides. And we have 2t squared plus 20t plus 48 is equal to 0. I can factor a GCF of 2 out, so I get t squared plus 10t plus 24 is equal to 0. And this would factor to t plus 6 and t plus 4. 6 times 4 is 24. 6 plus 4 is 10 and is equal to 0. So that means that t would equal negative 6 or negative 4. But since t was represented by time in seconds, we cannot have any negative time, no negative time. So that means, would it be possible? No, not possible for this triangle to be isosceles with A and B being the base angles. So our second example says if angle DAC is equal to alpha and triangle ABC is isosceles with a vertex angle of B, what must the numerical value for alpha be equal to? So what that means is we're trying to solve for alpha. So we need to be able to develop some kind of equation that involves alpha so we can solve for it, just like if alpha was x. So if you'd rather me use x instead, then we can say that alpha is equal to x. So our goal is trying to solve for x. We are told that angle DAC is alpha, or I'll use x instead, and that triangle ABC is isosceles with a vertex angle of B. So this is a vertex angle of triangle ABC. So this bottom triangle is isosceles also. We have two congruent sides. Here and here would be my base angles. So that means I can put x there because they would have to be congruent. Now, right here I've got a straight line. So I can call this angle 180 minus x on the other side. And now looking at this top isosceles triangle, I have a congruent leg, which would come over here to that base angle, and a congruent leg that would go to this base angle. So those two have to be the same. So if I'm going to find them, I would subtract what we have from 180. So 180 minus what we have is 180 minus x. and then I would divide that by 2 to find the two congruent base angles. So simplifying this, is going to give me x over 2. So that means that this angle is x over 2, and this angle is x over 2. So going back to the blue isosceles triangle, if I want to find this angle right here, I would take my triangle sum of 180 and subtract what you have, which would be 2x. So this angle is 180 minus 2x. So now we have all the different parts that we could have in this triangle. And I want to see if I can find a relationship which will allow me to solve for x. So what we are going to use is that knowing that the entire big triangle, triangle ABC is isosceles, and angle B is the vertex angle, then that means that this bottom angle C and this bottom angle X would have to be your base angles. And that means that they would have to be congruent. So angle A would have to equal angle C. That gives us an equation. Now we're just going to plug in the values that we have for those two angles. So I'm going to erase what I have to make some more room. Okay, so we know that A has to be equal to C. So my angle A was X. And angle C is made up of two different parts. It's made up of X over 2 plus 180 minus 2x. So now this is our equation that we want to solve. To begin to solve this, I'm going to multiply everything by 2 to clear my fraction. Every single part. So here to here to here and over to here multiplied by 2. So we have 2x. X over 2 times 2 is just going to be x plus 360 minus 4x. So 2x is equal to negative 3x plus 360. Add 3x to both sides and you get 5x is equal to 360. And x is going to equal 72. So we did what we were asked to do. We found the numerical value for x. So we're good. So this next question says, assume that AB is the diameter of the circle and O is the center. If angle DAC is alpha, prove that angle ACB would equal 90 degrees. So let's start out by adding this extra line in here so that we're able to have angle ACB. Alright, and angle DAC was given as alpha. So now we need to prove that angle ACB is equal to 90 degrees. So let's start out with just what we know. We know if this is the center, then these three line segments are all a radius from the center to the outside, and all radii in the same circle are congruent. So that gives us two isosceles triangles that we can work with. So looking at triangle AOC, if these are my two legs, then these would be my base angles. So the first thing that we know is that angle OCA would be equal to alpha. And we know that because of the base angles theorem. The second thing that we would know, we have to now look back at our picture, and using the exterior angles theorem, if I know that interior plus interior would equal exterior, which is this angle right here, then that angle would be 2 alpha. So angle BOC is going to equal to alpha by the exterior angle theorem. So now looking at the second isosceles triangle in the picture, this is O, B, C, and that is 2 alpha. So to find those up, now here are my legs, so that would give me those as my base angles, so they have to be congruent. To find them, I would subtract what I have from 180 and then divide by 2. So it will become 90 minus alpha. So I know that angle OBC is equal to 90 minus alpha, and also angle OCB is equal to 90 minus alpha. And I was able to find that by the triangle sum and base angles together. So now I want to prove what angle ACB would be. So angle ACB is made up of angle OCB plus angle OCA by angle addition. And now I can substitute in what I know. So angle ACB, in what we have written, OCB is equal to 90 minus x, 90 minus alpha. And plus angle OCA, we have equal to alpha. So I just substitute it. And then my last step, I can simplify angle ACB is equal to 90 degrees. So what I wanted to prove was that angle ACB would equal 90 degrees, and that is what we did. Okay, so this last question says if segment AD is the angle bisector of angle EAC, prove that triangle ABC is isosceles. So AD is the angle bisector of EAC. So angle EAC is this angle up at the top, and we know that it's bisected by AD, so we know that those two angles have to be congruent. So now we're trying to prove that triangle ABC is isosceles. So we need to either show that there's two congruent legs or two congruent angles. Since we're given angles, we're most likely going to be able to find two congruent angles in that triangle. Now the other piece of information we're given is that this line and this line are parallel because of those arrows on them. So that could be helpful. So let's draw those outside of the picture. And now I'm going to look at this line up at the top as my transversal. So I'm going to draw that. Okay, so I have these parallel lines and I drew that top line as my transversal. I already know this angle right here is marked off in my picture. And I could get another angle that would be congruent to it because these two angles are corresponding angles and the lines are parallel, so they have to be congruent. So that is the first thing that we know. We know that angle ABC is congruent to angle EAD because they're corresponding angles. So we have one angle in that orange triangle that we're trying to prove, so now we need another one. So let's look at those same parallel lines. I'm going to draw them outside of the picture again. But now instead, I'm going to look at this line as my transversal. Now I already have this angle marked off as congruent. I now can conclude that this angle would be the same because those are alternate interior angles and the lines are parallel, so they have to be congruent. So that's the next thing that I know. I know that angle BCA would be congruent to angle DAC because they are alternate interior angles. So I'll put that in my picture also. And now I have two congruent angles in triangle ABC. So I'm able to conclude that triangle ABC is isosceles. So now I just have to write it. So triangle ABC is isosceles because there are two congruent base angles. And we're done.